Hello everyone, I'm Mr. Furlong, and today we're talking radiation. We are surrounded by radiation. In fact, 85% of all the radiation that we encounter every day is from natural sources. The biggest, of course, is radon, which is coming up from the ground. But then we get things like cosmic rays, rays from food, and when you think about radiation and you think about things like a nuclear power plant, very little of our radiation comes from sources like that. So what exactly is radiation? Well, we're going to look at three different types of radiation today. The first are alpha particles. You can see the Greek symbol for alpha in the parentheses, and this consists of two protons and two neutrons. Essentially, it's a helium atom that is going to escape the nucleus. Now, alpha particles inside of cells can be dangerous. They can wreak havoc on things inside of cells. But we use alpha particles for things like smoke detectors. So how a smoke detector works, we have a source, a radioactive source called americium that is in the smoke detector that is releasing these alpha particles. Now these alpha particles are traveling from the source up to a metal plate. The metal plate is of course connected to the battery. And if smoke comes in, so here we see some smoke particles, and blocks these alpha particles, it will disrupt the electrical current and a sound will go off saying that there is smoke in the room. Now when an alpha particle is released, we actually change the element that is there. This is called transmutation, the process of changing from one element to another. For example, here we have polonium-210. If it releases an alpha particle, remember an alpha particle is just basically a helium, it's two protons and two neutrons. We end up with lead-206. Now how do we get this? Well, if we started off with 210 as the atomic mass and we just lost 4 atomic mass units, we now have a new mass of 206. So 210 minus the 4 equals the 206. We start off with 84 protons, we just lost 2 of them, so now we're down to 82. Remember, the number of protons tell us what element it is. On the periodic table, an atomic number of 82 is lead. So some elements that release alpha particles is americium-241 in our smoke detectors, plutonium-238 and uranium-238, radon-220. Another type of radioactive element is a beta particle. There we can see the Greek beta sign. A beta particle is a neutron that decays into a proton and electron. Now remember, that's really what a neutron is. It's just a little proton, and flying around it is its own electron. And the electron will be emitted, which means that the atom now gains an extra proton, but the mass stays the same because the electron doesn't really have much of a mass. The beta particle does have a little bit more energy than an alpha particle, but it can simply be stopped by a little bit of foil. Now let's take a look at an example of this. Let's say that we have iodine-131. Iodine has an atomic number of 53. And it releases an electron. Now electron doesn't have any mass, and we actually end up gaining a proton. So now what we have, if we look on the periodic table, this substance has 54 protons now, which is xenon, and the atomic mass will stay the same. So some elements that release beta particles are things like cesium-137, cobalt-60, iodine-131, and strontium-90. The last type of radiation are gamma rays. Gamma rays are high-frequency electromagnetic radiation. We'll talk more about electromagnetic waves in another unit. And this is pure energy, so it's not losing any mass at all, and we're not changing the number of protons or neutrons. And gamma rays, because of the amount of energy that it has, is able to pass through lots of different types of materials. One of the things that we can use gamma rays for is, though, to kill bacteria on fruit. So here we can see 2 types of strawberries, some that were given gamma rays, others that were not over a period of time. Notice the ones that did not get the radiation, they're starting to mold up, and again because of the bacteria that is living on them, whereas the strawberries that did receive the radiation still look pretty good to eat. These gamma rays are also part of the cosmic radiation that literally is all throughout space. So we're constantly in contact with these different types of gamma rays. What we don't really want to do is have a large amount of gamma rays focused in on us, because that can have some bad side effects. Like, well, you know this guy.